Hey everyone, welcome back to my channel, where we dive into the world of coding and explore the most interesting problems on LeetCode. Today, we're going to tackle a medium-level problem called search in rotated sorted array. This problem is all about finding a target element in an array that has been rotated. And it requires a clever approach to solve efficiently. So, let's get started and see how we can crack this problem. The problem statement is quite straightforward. We're given a sorted array that has been rotated an unknown number of times. And we need to find a specific target element in this array. The catch is that the rotation can be anywhere in the array. So we can't simply use a linear search or a standard binary search algorithm. We need to think outside the box and come up with a creative solution that takes into account the rotation. So, the core insight here is that even though the array is rotated, it can still be divided into two halves where one half is sorted. Think of it like a puzzle, where you have a sorted array that has been rotated, and now you need to find a specific piece of the puzzle. By identifying which half the target element could be in and adjusting the search boundaries accordingly, we can apply a modified binary search algorithm to solve the problem efficiently. It's like using a map to navigate through a rotated landscape, where you need to adjust your direction based on the terrain. Let's walk through the thought process behind this problem. Imagine you're searching for a specific book in a library, but the library has been rearranged, and the books are no longer in alphabetical order. However, you know that the books are still grouped by category, and within each category, they're in alphabetical order. You can use this information to your advantage by searching for the book in the category where it's most likely to be. It's similar with the rotated array, where we can identify the sorted half and search for the target element in that half. Now, let's take a look at the C++ code that implements this approach. We start by initializing two pointers, left and right, to the start and end of the array, respectively. Then, we calculate the middle index using the formula mid equals left plus right, left. 2. We compare the middle element to the target, and if they match, we return the index. If not, we determine which half is sorted by checking if the left element is less than or equal to the middle element. If it is, then the left half is sorted, and we check if the target is in the range of the left half. If it is, we adjust the right pointer to mid 1. Otherwise, we adjust the left pointer to mid plus 1. If the left half is not sorted, then the right half must be sorted, and we apply a similar logic to adjust the pointers. We repeat this process until we find the target element or the pointers meet. The time complexity of this solution is O log n, where n is the number of elements in the array. This is because we're using a modified binary search algorithm that divides the search space in half at each step. The space complexity is O(1), as we're only using a constant amount of space to store the pointers and the target element. And that's it, folks. That's the solution to the search in rotated sorted array problem. I hope you found this explanation helpful and that you now have a better understanding of how to approach this type of problem. If you did, be sure to like the video, subscribe, and comment your approach below.